Good morning. My name is Rosa Arias. I'm the coordinator of the DNOSES project. I work for Ibercivis and I'm the founder of Science for Change. I have been involved in odor pollution since 2004 and I'm the creator of the Odor Collect app. I'm going to explain you the results of the Barcelona pilot obtained in the framework of the DNOSES project, where we use citizen science and participatory mapping for odor impact assessment, considering the real perception of the receptors. I'm going to explain you the framework of our pilot case study, then the analysis of the results obtained from the other observations, and the conclusions. So we are working in the Forum area of Barcelona. It's an area in an urban context by the sea. It has had historical odor issues since the late 70s, early 80s, because a variety of emitting activities are placed there. And also a variety of socio-cultural realities are there, because it was used to be a depressed area of the city, but it has been refurbished lately and a new harbor has been built and a lot of buildings with new people coming. So we wanted to test all this variety of other sources and complex social realities to see how our methodology could work. We have a waste incinerator and an integral waste treatment plant. So the odors emitting are from the incinerator waste odor due to the trucks, and also ash odor very close to the disposal area. And from the integral treatment plant, we can smell fresh waste, decomposed waste, waste also coming from the trucks, leachate very close to the source, sometimes very, very uncommon biogas or digestate. This water treatment plant and the sludge treatment plant will have a different type of smells, as you know. This was the aspect of the area back in the 70s. This was the old wastewater treatment plant, the biggest in Catalonia. And now, after the refurbishment of the area, everything has been situated beyond this square in the Forum area, so you cannot see anymore the basins. So the smells associated to these activities are freshwater smell, wastewater smell, rotten eggs, or a smell from the biological treatment, which is the more frequent one coming from the wastewater treatment plant. And in the case of the sludge treatment plant, the more common odor in the area is sludge, and also the stronger one and the more annoying, and the sludge smell due to truck circulation. Also, we have some other potential odor sources in the area, such as a pneumatic waste treatment plant. The sewage system also causes complaints, and also a big deposit of wastewater located in the Taulat Street. We wanted to apply a citizen science methodology, very inclusive in the area, to involve citizens in the monitoring of the odor pollution. Having into account that our nose is the best sensor to measure odors, we want to involve any type of citizen, so any literacy levels, any gender, and any sociocultural and socioeconomic realities. In our case, we also want to involve the citizens in all the phases of the research, from the very definition of the research question to data collection, data analysis, and action. To sum up, this is our model. We have 8 phases for the engagement and the data collection and analysis, and we run these phases in an iterative process. I'm going to explain you first the 4 first phases of the model, including the stakeholder mapping and the co-design of the research. So we started in July 2018 until January 2019 with the identification of the problem and the stakeholder mapping. To do that, we did research on previous other studies and on the social context. We had meetings with the key actors, such as the metropolitan area of Barcelona, who is in charge of the other emitting activities, since they deal with waste and wastewater, and also with all the emitting activities. We had visits to the plants, etc., and also with the main citizen association complaining in the area, which was called IDENET. We did together with them the stakeholder mapping, so we identified the main stakeholders from the quadruple helix that we wanted to involve in our pilot, and we identified potential motivations and barriers to Then we started with phase 3, framing the problem. From January to April 2019, we did field ethnographic research. So we mapped all the public venues that were useful for engagement. We participate in community events. We did the recruitment of participants. We had the first conversations with the neighbors, and we had communications also of the project in local media and beyond. We start framing the problem, but to do that, we decided to run a pre-pilot because we wanted to test first the methodologies. Since the DNOSES pilot in Barcelona, it was the first pilot and wanted to act as a model for the rest, we wanted to start with a small, reduced number of people so that we can test very quickly and in an effective way the methodology. So we had a series of workshops and interviews where we meet with the citizens and other actors to first understand the issue, also from their perspective. Then we did some other training, and we showed them the Other Collect app where we are collecting the data, so they learn how to do good other observations. And then we collect the data for 2 weeks, and we run interviews with the people involved for doubts and feedback. And finally, we did a very first round of data analysis and co-design of the hypothesis and the actions. After this, we started the real pilot. So it lasted from May 2019 until June 2020. So our objectives were to have one workshop per month for data collection and data analysis with the citizens, because we needed to provide them feedback. We had constant onboarding of new participants and continuous data collection. And we participated a lot in community events and did a lot of dissemination actions as well. Some of the activities, though, were affected by the COVID pandemic, as you can. To collect the data, use the app Other Collect, which allows people to co-create collaborative other maps by gathering real-time other observations. And as I mentioned before, we train the citizens. As you can see in these pictures, we ran several workshops where they were facing some other samples to evaluate the character of the odor, the hedonic tone, and the intensity. And also we did sensory walks in the neighborhood, so that we were facing, looking for the smells coming from the different activities, so that citizens can recognize them and then map them correctly in the app. The app, it's very simple to use. We work with open data, so you can see all open data just connecting or by entering the website. But to report a new odor, you need to be registered. So the first step, when you perceive an odor anywhere in the street, where you in your working place or in your living place, you need to select first the type of odor. The main types are waste, wastewater, agriculture, livestock, food industries, industrial odors, urban odors, and nice smells. You need to grade the odor intensity and the hedonic tone. We use the scales in the VDIs so that we can compare with other methodologies. And we have the analysis of the result obtained from these other observations, which I'm going to present. In total, for the pilot, we have 563 other observations reported in Other Collect for this period of 12 months. More than 50 neighbors were involved in the collection of the observations, and the observations frequency varied depending on the intensity of the citizen participatory activities that we ran throughout the year, and also according to the lockdown periods associated to. These are the results on the types of odors and subtypes of odors that we perceive. To start with, the wastewater odors were the more frequent ones, with a 52.5%, followed by waste, 26.3%. This is totally in line with the expected results due to the emission activity in the area, and it's totally aligned also with previous traditional odor studies that we knew that have been made in the area. Also, these percentages were the same from the very beginning of the pilot until the end, so there was a high degree of data consistency throughout the pilot. For the waste odors, most of the reported observations were associated to decomposed waste, Ibercivis with a 63.5, and only the 12% was associated to fresh waste. We have the suspicion that maybe some of the decomposed waste reported may be, in fact, a sludge smell, but we need to further investigate this fact. Then, for the wastewater odor distribution, we have basically 65% of observations corresponding to sludge, and also 22% more or less to wastewater smell, in line also with traditional. Then you have here the percentage of the intensity of the reported odors, the total intensity, the wastewater intensity, and the waste intensity. Tone. This is understood in this table, which is a summary. You can see the frequency, which, as was mentioned before, wastewater smells were the more frequent with a 52.5%. But you can see that the intensity and the hedonic tone reported for waste odor are higher intensity and lower hedonic tone as an average, which indicates a higher level of annoyance for the affected community, even though this type of smell is less frequent. Then we decided to run an analysis by hours to see how these other observations were evolving. We have these 4 time slots, and the other reported were in line with people diurnal activities, because of course at 9 citizens are sleeping, so they cannot report other. We run the same analysis per type of odor. We see that for every time slot, the observations for wastewater always surpass waste smells, which was what we were expecting. A more clear correlation will be established with industrial operations if we start working with the emitting activities, which is one of our next steps. Then we divided even more the time slots. So we analyze them just every 2 hours. And if we do not consider the night hours where people are sleeping, we see the evolution. And we see that between 8 and 20, at 22 hours at night, the observations related to wastewater increases by large, especially suggesting a correlation with the specific industrial activity in this period of time, specifically with the start of the sludge truck circulation. We go down just for the wastewater odor type, we see that sludge is the most frequent observation for all the time slots. During midday, sludge and wastewater are similar though, but we can start seeing the activity associated to the trucks in the late hours. So we can really see this activity in the observed data. Then we continue the analysis, trying to analyze potential other episodes. In this slide, you can see our other episodes reported. We consider another episodes as a period of 2 hours that has more than one observation. In this case, we didn't differentiate between type of odors. So we see that from the total of 433 days where we have observations, in 110 days, more than one other observation was collected in a period less than 2 hours, so the 25% of the times, mostly on those periods where citizen participation has been fostered. The percentage is higher in the periods with more citizen participation. We divided these episodes per type of odors. So you can see in the legend that the blue color corresponds to the wastewater and the brown color corresponds to waste. In this case, wastewater is the category with more odor episodes, also as it was expected. And waste and urban waste are in the second place. Urban waste, it was quite funny because it started towards the end of the pilot to be perceived. It was a smell that was not foreseen at the beginning, but it was first no identified source. But in 2020, a new crematorium was set in place in San Adrià. So, as you see, at the end of the pilot, we recorded a lot of observations coming from this new source of. And here, finally, you can see the total number of other observations by episode. The episodes are counted as days with these observations in periods of less than 2 hours. And we can see that per type of odors, some of the days you have a wide variety and a big number of observations. This corresponds to the days where we were running participatory activities, but then we can see some other episodes where they have only one smell perceived. So these are the most important ones for the analysis, and most of them correspond again to wastewater. Conclusions. We think that the citizen science methodology deployed allow us to monitor and objectivize the odor impact from the receptor point of view in the forum area. The results obtained perfectly reflect the results from traditional odor studies, which included olfactometry and dispersion modeling, and also field inspections that were previously conducted in the area, where it was seen already that the main meeting activities were the wastewater treatment, especially in relation to the sludge. The analysis by time slot is consistent, and it reflects the activity of the trucks transporting the sludge from 8 hours onwards at night, and the other episodes allow to identify situations of maximum impact in the area. Then our next steps are several. We aim to deeper the analysis per time slots, impact area, type of odors, and the relationship with intensity and hedonic tone. We also want to include meteorological data and dispersion modeling to calculate the route trajectories and verify the plausibility of potential origins, the emitting activities, to validate the typology of the other observations. We aim to correlate the other episodes detected with industrial operations from the emitting activities, if we manage to have their collaboration on this. And this will allow, of course, to identify good practices and to establish other management plans to reduce the impact over the population. Advantages of the proposed methodology are a lot. We think that citizen science for environmental monitoring on ambient odors can be very useful for both environmental authorities and other emitting activities, as it provides evidence and a new set of data showing geolocalized odor perception in real time. So like this, we can obtain real-time data from odors perceived by affected citizens to understand where and when those odors occur, and we can establish odor management plans accordingly. We can increase the understanding of the effectiveness of the established systems for odor abatement and control. We can better manage industrial operations thanks to the data gathered in odor collect to reduce the overall impact on the population. We can promote transparency with emitting activities participation, and we can improve also the relationship of the emitting industries with affected citizens, the municipalities, and the environmental authorities. So thank